You step onto the deck, press the power button, and get absolutely nothing. The dashboard stays dark, the motor is silent, and your primary transport is now just 40 pounds of dead weight. Most riders assume this means the battery has reached its end of life. Replacing a high-capacity lithium-ion pack can cost anywhere from $300 to $600, which often leads to people scrapping the entire machine. In reality, 80% of these dead scooters are actually functional. They are governed by a protective ecosystem of fail-safes that lock the system down when they detect a specific user error or environmental threat. To get moving again, we use an escalation framework. We troubleshoot from the absolute cheapest, zero-tool fixes, and only move toward complex hardware diagnostics if the simple layers remain locked. Systematically walking this path is the only way to ensure you don't throw away a perfectly good vehicle over a tripped sensor or a $2 fuse. Level 1 covers the facepalm fixes. Premium models frequently use a two-step start sequence. You may need to turn a physical key to the on position before the dashboard power button will respond to a 3 to 5 second hold. Mechanical interlocks also play a major role. An engaged kickstand, a misaligned brake lever, or a kick-to-start setting prevents the motor from engaging at a standstill. If you haven't pushed the scooter to 3 kilometers per hour, the throttle will stay dead by design. If the dashboard lights up but the wheels won't spin, the issue has moved into Level 2, the digital brain. This shows the standard digital interface where the scooter communicates its health. Pay attention to the numbered indicators. A 5E error signals undervoltage, while a 9E indicates the controller overheated and requires a cooling period. When the software freezes, you have to force a reset of the battery management system. Some decks feature a dedicated reset button you hold for 15 seconds. If that's missing, a 10-minute physical battery disconnect will drain the residual power and clear the controller's temporary memory. Performing this system wipe can resolve deep software lockouts, restoring full functionality without requiring a single tool or a replacement part. Level 3 focuses on the physical power path. Before blaming the scooter, verify the wall outlet and the charger itself. If the indicator lights on the charger brick aren't behaving normally, the fault lies in your charging cable, not the battery. Next is the inline fuse. If the system detects a minor power surge, a small filament inside this fuse is designed to melt. This breaks the circuit instantly to prevent the surge from reaching the expensive motor or controller. These fuses are often tucked away at physical junctions, like these white plastic connectors. You'll usually find them hidden under the deck plating, bundled near the main controller, or secured directly behind the charging port. If your scooter died after getting wet, the protocol changes. Never attempt to power it back on to check it, and keep hairdryers away from the deck. High heat can actually steam the internal electronics, accelerating the damage. The proper emergency fix is a 48-hour drying phase. Disassemble the accessible panels and use silica gel or uncooked rice to pull moisture out of the internal compartments in a well-ventilated area. Most water-related failures happen because electricity is introduced to a wet circuit. Cutting the power immediately and allowing for a full evaporation cycle can prevent a minor leak from becoming a terminal short circuit. If the software is clear and the fuses are intact, we reach Level 4, hardware triage. To move forward, you have to test the battery's actual output with a multimeter. Connect multimeter probes to these battery terminals, set to DC voltage. A low reading indicates a failing pack. You must also monitor it under load. If voltage drops sharply when the motor draws power, the internal cells have degraded beyond repair. The controller is the gatekeeper between your battery and motor, interpreting throttle input to release current. When it fails, the ride becomes unpredictable, causing throttle lag, jerky surges, or random power drops while cruising. Because these symptoms look like battery issues, many riders spend hundreds on a new power pack they don't need. Identifying a degraded controller early is the most effective way to avoid the highest repair costs. Reviving the machine changes the way you look at it. You have mapped the electrical anatomy under the deck, turning a mysterious breakdown into a solvable puzzle. Preservation is now the priority. To keep the battery healthy, recharge it before it hits 0%, and avoid storing the scooter in extreme heat, which can rapidly diminish its capacity. Physical habits matter too. Keep the deck seals intact, avoid deep puddles that can breach the motor, and ensure the kickstand sensors remain free of debris and road grime. These machines operate as a sequence of logical gates and physical loops. They respond to specific inputs and fail according to predictable patterns. Checking the cheapest failsafe first and respecting the hardware's thermal limits turns a potential breakdown into simple, manageable maintenance.